All right, so welcome. Glad to see you guys here. This presentation is on data collection and regulatory requirements. So we're going to talk about, how much data do you need to collect in order to meet regulatory requirements? I actually put this together about a year ago at the request of one of the board members of Intellect, because he was being asked these questions about how much data do I need to collect. So does anybody have any notions about what you might think before we even start talking about how much data do you need? How much data is good enough? Nobody? Got nothing?
How would you determine how much data is good enough?
That's a great question, Enoch. That's exactly the question I'm going to strive to answer today, because really, you can't just answer that question. What would be the presumption, right, in most operating companies? More data is better, right? That would be the presumption. But data costs money. It costs money to collect it. It costs money to store it. It costs money to manage it. It costs money to do something with it. And many organizations, I would put to you, are drowning in data, and they're starving for information, right? So really the purpose of putting this together was to answer the question of, well, what do I need the data for? So let's start by defining a SCADA system. So this context is more around SCADA data than other kinds of data. Certainly there's other kinds of data we can get to, but primarily this conversation's about SCADA data, or you think of that as operating data. So in our world, SCADA means supervisory control and data acquisition. The emphasis here is on supervisory control. So in a SCADA system, where does control exist? Pardon? Locally, right, at the remote facility, right? So, and the reason for that is the most unreliable part of any SCADA infrastructure is the remote telemetry. It's the thing that's impacted by weather and power and all kinds of other things. So we want to maintain control of the processes even if we lose telemetry. So in SCADA, it's supervisory control. So, because all we're doing is we're saying control to a new set point, control to a new pressure, control to a new flow, but the actual control is in the PLC or the remote device at the field. So the cost of this infrastructure that we build to run these remote facilities, it's kind of a pyramid, right? I've got to get everything instrumented. And then I get all those instruments, I got to bring them into an RTU or a PLC or an EFM, some kind of field automation device. And then I've got to build in a telemetry infrastructure, communications infrastructure, and then I've got to get that data back onto the network and into some databases, onto some servers, and then and only then can I do anything with the data, right? So the cost of data is high if you have no infrastructure, but inexpensive if the infrastructure exists, right? So if I've already got my telecommunications backbone, the cost of getting the data is cheap versus I have no telemetry backbone, right? So what tends to happen is we justify these big capital projects to put in a telemetry infrastructure, and then everybody wants data, right? And everybody's looking for reasons to rationalize why I need more data. Would y'all agree with that premise?
Yes.
Yeah, okay. So the other thing that's interesting about this is that while the equipment cost is more in the field, the human resource cost is more as we go up to the top of the pyramid, right? Because it's at the top of the pyramid that I actually start adding applications. I'm doing nominations, I'm doing flow control, I'm doing balances, I'm doing modeling, I'm doing leak detection. It's only at that top level do I start actually getting the value of the data, and that value is based on advanced applications and smart dudes and ladies working with that data to make it meaningful, right? All right, so what I'm driving at is the value is created as we go up this chain, right? So just to build a little context, right? So really, data is inexpensive if I have the infrastructure, but what I'm doing with the data is still expensive. Is this making sense? Because I've got to throw people at it, I got to throw applications at it. And what's interesting is when you get to these advanced applications, the more advanced the application, the more costly the software to procure and maintain, and the more costly the human resources to manage it, right? So, the other part of this is in today's world. If you look at SCADA 15 or 20 years ago, and I'm old enough to remember that, I'm actually old enough to remember further back than that, but that's a different story. If you look at SCADA 15 or 20 years ago, it really was just about get me the data on a screen. That's all we were trying to do, is get the data from the device to a screen. Well, the world has changed, and the expectations have changed around all this. So now I'm starting to look, how do I take this SCADA data and make it available to other business applications? How do I make it available to leak detection? How do I make it available to machinery analysis, right? So what's interesting about those kinds of things, it's engineers that want that data for analytical purposes, right? Operators in the control room, they want more data. They want to know about how many alarm activations, when are they coming in? They want to do analysis about those alarm activations and how does all that work together, right? So what's happening is we're starting to bolt and put more and more demands for the data on the system that's collecting the data, right? So a lot of this is clunky, right?